and welcome. Hi, everyone. This is Aurora. If someone was to say to you, what is percent? What would you tell them? If they said, what are you studying? And you said, I'm studying percent. And they're like, what's that? And they're like 7 or 8. So keep it simple. Don't be too techie and geeky on them. All right, what would you say? Go ahead and drop it in the chat right now while I pull you down to my desk. Okay, so what would you say? What is a percent? Let's take a look at my definition. Percent, so I'll say a percent, is another way to write, I know the camera needs to be a little adjusted. There we go, is another way to write and here's the word that everyone loves, fraction, where the denominator, so the bottom number, denominator is the word I have trouble spelling sometimes, is, and this is the important part, 100. That's the definition of percent. It's another way to write a fraction. The denominator is 100. Okay, what do I mean by that? If I said 73 over 100, that's a fraction. Okay, there's 100, it takes 100 to make a whole, and I only have 73. So what does that mean? I take the top number, rip it off, and then put the percent sign. So 73 over 100 is the same as 73%. All right, now you do one. What if I said 62 over 100? What would the percent be? Go ahead and you can tell me out loud or you can type it in the box. Yes, it is part of a number, that's right. So, yeah, it takes 100 for the whole, but I only have 62 of them. Yeah, so it's 60, that's right, 62%. Give me a smile if this makes sense so far. It's just a fraction, denominator is always 100. That's why we like it with decimals, because decimals is based in 10. All right, so here's where people usually start with fraction, or I'm sorry, with percent. And they'll ask you something. Have you ever been shopping? And they'll say 30% off, 40% off, right? And you're like, okay, how much is that? What is 30%? Say you're looking at something for $50, okay? And it's got a 30% off sale. All right, so you're wondering, well, how much am I really saving? Is that $10? Is it half off? Like what is it? Okay, so let's find out. Anytime you see 30%, I want you to write it as a fraction. So how do we write 30% as a fraction? We just did this, but the other way, right? You're going to write 100 on the bottom, and then whatever this number is before the percent sign just goes on top. See? Okay, so here we go. 30% of is multiply 50. There, we just wrote the equation. So what is an unknown, that's x, is equal. What is 30%, 30 over 100, of is multiply 50. So I just translated in English into math. Isn't that fun? All right, can you do this problem? Sure. What's 30 times 50? Now if you don't know your 30 times tables off the top of your head, that's okay. Can you do 3 times 5? What's 3 times 5? Yeah, it's 15, right? And then add 2 zeros to the end. So I have a 15 with 2 zeros, put them back in, and then divide by 100. I have a 0 on top, I have a 0 on top and bottom, so I have 15 over 1. So x is 15. What does that mean? That means if you're buying something, say like, what would be $50? Skateboard, maybe? I'm not even sure. Okay, so you're buying something for, calculator, there we go. You buy a calculator, you're in a math class, $50, but it's 30% off. What they're saying is, what is 30% of, so you're saving $15. So is the calculator $15? No, it's $15 off the regular price if it's 30% off. Here, give me a little bit of a smile if you kind of see what we're talking about. Oh good, lots of smiles, nice. All right, so these questions, do they feel confusing sometimes? Like, what is this? What is that? Yeah? Okay, so let's spend a little time on that. If I say 76 is what percent of 50? Okay, so I tell my daughter, all right, I need you to make 50 cookies. She comes back and she says, well, I made 76. So I say, okay, so I might ask her, what percent is that? Like, just for fun, right? So let's translate the English into math. So 76, that's a number, we like that. Is, do you remember what is? Well, that didn't come out right. Do you know what is? Yeah, equals, love it. I see the hand jive there. What, 76 is what? So you put an X there because we don't know what this is. What percent? Ooh, hello. What percent? Do you see how this is translated to what percent? X over 100? I know it's going to be over 100 because it's percent, but I don't know how much, okay? Of, what is of? Show me with your arms. What is of? Multiply, good. All right, now does this look confusing? I got an X here and an X here. Doesn't that look confusing? All right, so with your permission, I would like to suggest a change. I would like to suggest instead of a multiplication being an X, we just use a dot. Can we do that? Okay, so now these are different. So what percent of, and then we just drop the 50. So 76 is what percent of 50? Do you see why I wanted to talk to you, the Zoomers that were on early? I was like, oh, we're going to talk about secret codes. Do you see how it's kind of like a secret code? You have to like decode the sentence, yeah? All right, so what do we do now? Okay, so now we have to figure out what do we want? We want this, but it's a little buried. Would you agree it's a little buried? Okay, so if I want the X by itself, I can write 76 equals X times 50 over 100. Okay? 50 over 100. How do I make this go away? I could go like this, but how do I make it go away for real? So if I multiply by the opposite, and we do a handstand here, watch this. Do you see how this is going to make this go away? Look, 50 over 50, this is a fraction, right? 50 divided by 50, this means you have 50, it takes 50 to be a whole, and you have 50. So this is 1. Let me bring the camera down a little bit. Okay, so that's 1. So here's a 50 divided by 50. Here's 100 divided by 100. That's also 1. So I just got X all by itself. So I got rid of this. And I can do that as long as I do it to the other side. This is probably the trickiest part of the whole thing. I can multiply by any number I want as long as you do it to the other side too. Okay? All right. So what does this mean? This means the 50 cancels with the 50. The 100 cancels with the 100. So what do I have? I have this. X is equal to 100 over 50 times 76. What is that? That's just a number. Look, 100 times 76 divided by 50. And you can use a calculator if you'd like. Once you're in Unit 3, we do allow calculators. So if you have one, we can have a little race. Okay. Here, let me get it in a spot where you can see it better. Is that a little better? Maybe? Okay. We have 100 times 76 divided by 50. Okay. So my daughter made me 152% of the cookies I asked for. So she gets to eat 52%. I'm going to take the 100%. So what did we just do here? So basically what we're doing is, so look, you can have more than 100%. Absolutely. So I can have a fraction. So 152 is over 100. That's the fraction that's equal to this. Do you see how the top is bigger than the bottom? That's okay. That's allowed. It looks a little weird. It looks like it's going to fall over because it's a little top heavy, right? But this is allowed. So anytime the top is bigger than the bottom, you're going to have more than 100%. All right, should we try another one? Okay, let's try another one. All right, can you guys give me your favorite number? I just need some numbers right now. Just type in your favorite number. Okay, let's do another one. All right, so I'm going to pull one. Wow, that's your favorite number? That's huge. How do you even remember that? Okay, all right. Okay, here. Let me pick a couple. If I said, what is 10% of 1,200? So what is, okay? So what is 10% of 1,200? Okay, what is X? That's right, it's the equal sign. 10% is 10 over 100. That's how we write our percent. It's always over 100. Of is multiply. 1200 is here. Can you do this one? 10 times 1200 divided by 100. Because everything is multiplication, I've got that 0 cancels, that 0 cancels. I now have 1 times 120. So x is 120. You can also use a calculator. You can say 10 times 1200 divided by 100, and you'll get 120. What if I said not 10%, but what if I said what is 1% of 330? I said, okay, tell you what. I have a bag of 330 M&Ms. You get 1% of them. How many am I giving you? Okay, so let's translate. Okay, so here we go. We're going to decode this. What is x? Is, tell me out loud, quick, 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 before I write it down. Equals, good. How do you write the 1%? Quick, 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 just shout it out. It's going to be 1 over 100. Whatever this number is in front, you just throw it down there. Of, what's the of? Do you remember what it is? Yeah, it's multiply. Good. And then you just write the 330. Is this process feeling a little easier? Yeah, kind of decoding it a little bit easier. Okay, good. So what do I have? This is equal to 330 times 1, which is 330, divided by 100. All right, so somebody had asked about turning a fraction into a decimal. So here's how we do it. You take 330, you take the top number, you push the divide button, and you put in the bottom number. And that is your answer. I have 3.3. So I give you 3.3. I guess I took a bite out of one of them. All right, so that is one way to convert a fraction to a decimal. That's a way you do it when you're an engineer, because the numbers are really kind of nasty. And I don't mean nasty, but like they're long and ugly, and it's not from your multiplication table. How do you take a decimal? If I have 2 over 5, how would you do that? To turn it into a decimal, the 2 goes in the box, the 5 goes here. Now, does that look familiar? So a fraction is just a little division problem. And here's the division problem. 5, that doesn't go into 2, does it? Nope. So here comes your decimal. Does 5 go into 20? It does. 5 goes into 24 times, and then it's even, right? There's nothing left over. The decimal gets pushed up. You put a 0 here so it looks nicer. So 2/5 equals 0.4. Okay, so once you have the fraction, just like this one, I could have said this is equal to 330 is in the box, 100 is out here. 100 goes into 333 times, divided by 300. We have 30 left over, and now we're going to have to go decimal point and 0, and this goes into 3. See how I get the same number? Yeah. Okay, good questions. Love your questions. Okay, I've got 2 more. Watch this. Ready? This is when math teachers get really creative. They do problems like this. And as a student, this is where you go, whoa, 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 hang on. You can't have a percent of a percent. Are you sure? Okay, anyone confused by these types of problems? No? Me? Okay, great. So what do? When they get kind of long and involved and confusing, what you do is you put your hand, you guys got your hand, get your hand out, and you go like this. There we go. Now, can you do this problem? Yes, absolutely. We just did it. So 10% is 10 over 100. That's right, it's always 100. Is of equal, or is of subtract, or is of, yeah, that's right, it's multiply. Multiply, 75. Okay, can you do this problem? You bet. This is 10 times 75 on top and 100 on the bottom, right? Because there's nothing on the bottom. This is 75. If you really want to convert this to a fraction, it's 75 over 1. It takes 1 for a whole, and you've got 75 of them. Okay, so 1 times 100 is 100. Okay, so I have, this is going to be 750 divided by 100. Okay, and so you can convert this to a decimal. That is going to be 750 divided by 100. So anytime you're dividing by 100, what you're going to do is you're going to take, let's see, where do I want to do this here? 750. There's a decimal point that hangs out at the end that's there if you need it. Do you see how there's 2 zeros here? Watch this. We go hop, hop, right there. So this becomes, so this decimal point gets hopped in because I'm dividing by 2 zeros, and 750 divided by 100 is equal to 7.5. Okay. So this is something, if you'd like to learn more about this, look back in Unit 2, about halfway through, about weeks 3 or 4, and we actually cover a lot of this. Okay, good. Notice how the top is bigger than the bottom. That means we're going to have something greater than 1 here. So we have 7.5, and that's bigger than 1. Okay, that's only part of it. So 10% of 75 is 7.5. So now what you do is you take your hand off, and for me, I'm going to use a piece of paper to block out everything and say, okay, this part here, this is equal to 7.5. Now we can rewrite the equation. 50% of, and any of this thing, which is equal to a number, 7.5. Do you see how it's just the same problem again? It's like this, almost the same thing again. Not the same numbers, but the same procedure. So 50% is 50 over 100. So just write the 50 and always write it over 100. Who can tell me what the word of means if we were to decode this into a math equation? No, it's not equal sign. Of is multiply. Of is multiply. Is the equal sign. All right, so, and then we just write 7.5. Make sure your multiplication dot is not the same as that dot. Otherwise, it'll get really confusing to have a dot 7 dot 5. Okay, and then what do? We multiply 50 times 7.5, and we have 100 on the bottom. So you can take your calculator and you say, all right, 50 times 7.5 divided by 100. So I have 3.75. So the answer to the entire problem is 3.75. All right, so you see how we did that. The first thing we did was we calculated this first part. That's what we did here. And then we said, okay, now I'm going to plug in a 7.5 here, and I'm going to say 50% of. So then it's a 2-part problem. Do you see that? It's a 2-part problem. Good. All right. Has anyone had any new furniture in their house lately? Any new furniture? Yeah? What have you guys had? Tell me in the chat. What have you guys had in terms of furniture? So up until about 20, maybe 20, for the first 25 years I was married, we only had one couch. We didn't have coffee tables. We didn't have any furniture. We had a kitchen table and chairs, and we had a couch, and that was it. And it was the same couch we bought years and years and years ago. So we had, when we went to a new house, yeah, new house means new furniture. And often parents get really excited because they get to like buy new stuff. And then usually it sounds something like this. Don't jump on the furniture. This is a terrible couch. You guys could do a better couch than that. But usually it's, right, because they bought a new couch. And so what I did is I actually, I bought an old couch. We needed a new one, and I knew I would say that, and I didn't want to say that, so we bought an old couch. And it was on sale, and I bought my couch for $50. Do you think I care if my kids jump all over it? No. Do you think the kids love that? Absolutely. So I bought 3 more. And so now they make all kinds of, and they throw things all over the place. All right. But our problem is, suppose we bought it for, suppose this couch was $400, so that was a true story. So $410 is the price tag of the couch. Okay, so we're here at a store. Your parents really like it, and they like it even more because it's under one of these signs. Right, that word is supposed to be save. Okay, buy now, sale, save, right? Here, let me bring this down. Okay, so you tell me how much is the couch. I'm going to give you 30 seconds. You write down the math equation you think we need to solve it. So what do you think we need to do? All right, you see a percent there, that's good. So what do you think? Okay. I'm going to do mine down here, and then we'll compare. So if you're stuck, write this as a decimal. That'll be your first job. Write 30% as a decimal. Okay. Question is, how much is the couch? All right, how are you doing? Okay, so if the couch is $410, and that's 100% of the price, right? That's all of it. Okay, if I want to know how much they're taking off, I would do this calculation. Do you see this one right here? Okay, so I have 30%, right, of 410. So let's figure out what that is. 30 divided by 100 times 410. I have $123. Here, these are dollars. Question, is that the price of the couch? You should be shaking your head like crazy. Your parents would be really happy if that was the price, right? What did we calculate? We calculated how much money they're willing to subtract from the 410 just to get you to buy the couch. Okay, so you could do it this way and then take this and subtract it from there. That's a totally valid way to do it. 410 minus 123, you could totally do that. Would you like to see another way of doing it? Look at this. What if you did 70 over 100? You're like, wait, where'd the 70 come from? Does it make sense that if it's 30% off, 100 minus 30 is 70. You're paying 70%, not 100%. 100% would be 410. You're paying 70% because 100 minus the discount is 70. So you're going to pay 70%. 70% written as a fraction is 70 over 100. Multiply that by 410. You guys tell me, what do you get? What do you get? Do you get 287? Excellent. That's the price of the couch. This is how much you don't have to pay, but this is the amount they're going to charge you. Yay! Big old smile if this is starting to make sense. Big old smile. Hey, love it, love it, love it. Okay, great. Okay, so now let's take a look at a different type of problem. All right, so stand up, shake it out, shake it out. Do a quick jumping jack, and here we go. If I have 7 over 8, I have 7/8 of something. You guys like to bake, right? 7/8 cup of flour, okay? That's how much flour I need. Okay, my question is, how many cups of flour do you need if you're going to make a recipe that is 8 times as big? So how much flour do you need? Ooh, I don't know. Okay, so that's a good question. So if I'm going to make an 8 times batch recipe, does it make sense that I simply multiply this thing by 8? Because I need 7/8, 7/8, 7/8, 7/8, 7/8, 7/8. We need that 8 times, right? So we simply multiply this thing by 8. I only now need 7 times 8, which is 56, divided by 8, which is 7 cups of flour. All right, give me a smile if you follow this. Like this makes sense. This makes sense. Okay, now let's change the problem a little bit. If I have a relationship where I have 7 cups of salt to 8, or here, wait, you guys probably like chocolate, right? 7 cups of chocolate for every 8 cups of sugar, okay? And that's the recipe for, oh, that was not a good example. Here, lemonade. Let's change it to lemonade. Okay, so I have, for every batch of lemonade, I use 7 lemons and 8 cups of sugar. Okay, that's fantastic. Suppose your little sister comes along and dumps in 64 cups of sugar. I know, right? How many lemons do you need to stick in there to even it out? I know, right? So she comes along, she goes, okay, I helped. Do you have a sister or a sibling or a cousin like this? They love to help. And you're like, oh, please don't. Okay, all right. You know that you need 7 lemons to 8 cups of sugar. She comes along and puts in 64 cups of sugar. She was busy for a while, nobody saw her. What do? No problem. You whip out your notebook and you're like, no problem, we can fix that. And then you say, let me teach you how to squeeze some lemons. So what we're going to do is cross multiply. We're going to say 7 times 64 equals 8 times something. Okay, so we have 7 times 64 equals 8 times. So this relationship needs to stay the same, or you're going to have pucker up juice or way too sweet juice, right? You need to have the same relationship, same ratio. Okay, so we want the x by itself, so we just divide by whatever's in front of the x, and that's an 8. 8 over 8 gives you 1. X is now equal to 7 times 64 divided by 8. Okay, who's got a calculator? Can you guys calculate that for me? I'll do it off screen here. Here, I can do it on screen. So my calculator doesn't always show up very well. 7 times 64 divided by 8. Did you guys get a number? All right, so how many lemons are you going to go? You got to go to the neighbor's lemon tree, don't you? So you're going to need to get 56 lemons. Yep, and this is where you say, let me teach you how to squeeze the lemons. And she's really excited because she loves to help, right? And pretty soon, you've got lemonade that you can sell and turn a profit. And because she dumped in so much sugar, you have to make it anyway, right? So you could sell the cups of lemon, you can sell the lemonade, right? Okay, so then this gets into a little more complicated. But there you go. So this is cross multiplication. All right, how was that? Was that fun? All right, now what about this? Suppose I have a chocolate bar, and the chocolate bar has 5 segments, and they're all equal, okay? And your favorite friend comes along and bites off a piece, and they take that much. Okay, can you write this, how much they've taken as a fraction for me? There are 5 slots, okay? 5 makes a whole. How much did they steal? I want you to write it as a fraction, write it as a decimal, and you bet, write it as a percent. Do that for me right now. Okay, go ahead. Okay, we're doing good. We're doing good. Okay, so if we are going to do this, how many total? 5. This goes on the bottom. And how many did they take? 1. So 5 of them makes a whole. They only took 1. That's 1/5. How do we get the decimal? 5 goes into 1. 5 doesn't go into 1, but it goes into 10. Anytime you start adding zeros past a number, you got to add a decimal point. 5 goes into 10 how many times? 2. And it's even. There's nothing left over. Push the decimal point up. Stick a 0 so it looks nice. Decimal form is 0.2. How do you turn this into a percent? All right. So if we say this number out loud, say it out loud. Not 0.2. This would be 2/10 is how we pronounce that. 2/10. Okay, percent is always over 100. So let's multiply the top and the bottom by the same number. This is a form of 1, right? 10 over 10. So now what do I have on the top? 2 times 10 is 20. 10 times 10 is 100. I have a number where the denominator is 100. That means whatever the numerator is going to be my percent. So this is 20%. If we look back at the picture, 20, 40, 60, 80, 100%. Okay, are we good there? How are we feeling about this? Feeling pretty good? All right, you guys ready to kick it up a notch? All right, so this was weeks 1 through about 3 that we just covered. Let's take a look at week number 4. How many of you like donuts? Anybody like donuts? Nobody likes donuts, huh? All right, well, I like donuts. All right, so 1 donut. Okay, now there we go. Now I'm getting the votes. Okay, 1 donut. I'm using some of your numbers you gave me before. 1 donut is $1.10. Anybody like hot cocoa? 1 hot cocoa. So I'm taking you out to a snack. 1 hot cocoa is $2.15. All right, so you add these up together. We've done this in decimals. The 5 comes down. This comes down to be a 2. You drop the decimal point. 1 plus 2 is 3. Is that how much they're going to charge me? Shake your head, no. Anyone living in the real world knows that we have something called tax. Okay. So in my state, tax is, let's say it's 15%. It's really high. How much more is my bill going to be? 15%, remember what that is, 15 over 100. The decimal form of this, see I've got 2 zeros, so you write the 15 down. There's a there's a decimal point right at the end, and then there's 2 zeros we're dividing by, so the number gets smaller. So we go 2 hops this way. So this is 0.15. So the tax is going to be this number, 3.25 times the tax, 0.15. Okay? Because if it was a 1, it'd be 100, right? And I'd be paying my bill again. But it's not. It's a part of the bill. How much? It's 15%. 15% is written as 0.15. So I take 15% of $3.25. Okay, so I take 325 multiplied by 0.15. I have 40.4875. Because we only use 2 decimal points for money, I'm just going to call that 0.49. Okay, so that's what this number is. This number is these two numbers multiplied together. We add them up, and then we have a number that is $3.74. Did I do that right? I think I did that right. Anybody out there like to leave a tip? Anybody like tips? Yeah, it's nice to leave tips, right? People appreciate it. So let's leave a tip. How much of a tip should we leave? It really depends on you. You could leave 10%. You could leave 20%. All right, if I left, say, a 10% tip, what would that be? Would that be a tip on this? Or would it be a tip on the amount, the original amount? Yeah, it's this part here. So let's leave a tip. And we'll say, let's leave 18%. Let's leave a weird number. 18% is 18 over 100. So remember, that's an 18, and we have 2 zeros, so we're going to go 1, 2. So this is going to be 0.18. So we're going to take 3.25 times how much we want to leave for a tip, 0.18, and that will give me a dollar amount. So this is 18% of $3.25. So whip out the calculator, times 0.18. I have, this is equal to 0.59. So we're going to leave them 59 cents in a tip. Okay, and this is my tip right there. So we had tax here and tip here, but remember the tip is based on the original. We don't tip on tax. And then you add these together. So I took you out for a donut and a hot cocoa, and I left a tip, paid my tax. My total bill, $4.33. All right, we good so far? Excellent. Okay. Now, if you have coupons and things like that, you'll want to make sure you take it off before this, and you pay your tax based on the new total. So if you had like 10 cents off, you take 10 cents off, and then the tax would be on a lower number. But when we tip, we always tip on the original amount before you take any discounts off. All right. Let's talk about 2 more things. One of them, these are both really easy. Percent error is one of them. And then percent change is the other. Let's say, for example, anybody like soda? All right, you have a can of soda, and it says 16 ounces. And because you love chemistry, you pour it into a container that can measure ounces, and it's got markings on the side. Okay, so you have a beaker, and you pour it in, and you realize it only makes it up to the 15.1 ounce. And you're like, hey, I got gypped. It says 16 ounces. So what they would ask you for is, at the factory, if you're an engineer, a manufacturing engineer, they would have a certain tolerance for how much is okay and how much is outside a tolerance, how much is not okay. And they use percent error to give a number to that. And percent error looks like this. It is the approximate minus the exact over the exact. And we multiply it by 100. Okay. What do you mean by approximate and exact? Okay, so for approximate is going to be this number here. The exact is what was printed on the can. This is the target. Okay, so this would be, so percent error. Let me write the whole thing with the numbers. Equals how much you actually got, 15.1, minus how much you were supposed to get, over how much you were supposed to get, and multiplied by 100. So if you do science experiments, and for example, the one we did this week for percent error, we calculated the speed of light using a chocolate bar and a microwave. and I asked you to compare what you got, what you calculated based on your experiment against the published value. And since the published value of the speed of light actually defines the metric unit, so that's as exact as you can get, whatever you did for your experiment would be the approximate. Okay, what are these bars? These bars mean if you get a negative number, see how the 16 is bigger than the 15? So we're going to get a negative number on top. It just means throw it out. These are called absolute value. And it just means we don't care if the number is positive or negative, just give me the numbers. Like, I don't care, don't give me that much detail. Okay, so percent error. So how this would look on your calculator is you would say 16 minus, let's see, I don't know if you can see that, 15.1. Okay, that didn't work. So here, 16 minus, here, 15.1, okay, divided by, so wait, something, it is pulling up a memory. Hang on, let me clear my memory here. We're going to have a calculator lesson at some point. Okay, so here we go. So I'll put it in here. 15.1 minus 16. All right, I have a negative 0.9. Throw away the negative sign because I don't care about it. That's what my absolute value bars mean. Divided by 16. And then don't forget to multiply by 100 because you want this number in a percent. So this can is off by 5.6%. And depending on the company, they will have a certain tolerance that they allow. So it might be plus or minus 5%, plus or minus 3%. It's up to the company how much you get, because when you buy a soda, next time you can measure it, you don't get exactly as much as in there. If you get like 3 or 4 sodas and you line them all up, they'll all be slightly different. And so this is something that they use when they make stuff. So for example, if you've ever heard of people making machining parts, they may not be able to use a part if it's out of tolerance. It means it's either too big or too small, and they use percent error to figure that out. Okay, percent change is the fun one. This is the one where we talked about how much things used to cost and how much they cost now. So if a pair of shoes, and I actually got real data for this, back in 1970 were $6.99. You tell me, how much is a pair of shoes today? Pair of shoes, anyone? Pair of shoes, pair of shoes. Here, I'll give you a second to tell me what a pair of shoes are while I write the equation. Percent change. Yeah, you can't get a good pair of shoes. You can't even get the shoebox for $6.99 anymore. Okay, so what is it? It's going to be the difference over the original times 100%. Okay, so shoes. Okay, I like that one. Let's do $79.99. All right, so $79.99, this is today, 2023. All right, so the years are just in there so you know which one is which year. I want the difference, and we're going to divide it by the original. In this case, original means the earlier price. Okay, so I'm going to have $79.99 minus $6.99 all over. And this is the important one because if you put 79 down here, you're going to get a different number than if you put $6.99. So this is the original. So the percent change, because you have to anchor down one of these points. So then versus now, you have to anchor down the then. That's what goes on the bottom. Okay? And we're going to multiply by 100 here, times 100. Okay, so $79.99 minus $6.99 divided by $6.99 times 100. How much did the price change? The price changed. The price percent change is 1,044%. So there has been a 1,044% increase in the price of shoes. Isn't that crazy? All right, tell me how tall you are. Do you know how tall you are? Can you put it in? Put it in there. And let me look at your percent change of how tall you grew. Okay, I'll make up one of the numbers, but you tell me what another number is. All right, I've got somebody saying that, okay, so I'm going to say last year you were 48 inches. Okay, this year, so that's last year. This year, okay, I'm going to grab one of yours, 53. Excellent. This year. So what's your percent change? Okay, so the difference is 53 minus 48. Who goes on the bottom? Tell me, which one? Which number goes on the bottom? This is the important part. Yeah, this is the one half of my students at the university get wrong, by the way. I know exactly where to go to look for their errors. Yeah, the original, so 48. Okay, 53 minus 48 is 5 divided by 48 times 100. Your percent change, if you were 48 inches last year and you're 53 inches this year, 12 months later, your percent change, you have a 10.4% increase in your height. And that's how much you grew. All right, isn't that fun? Okay, so I want to pause here for a second. How are you doing? How are you feeling about this so far? A little bit better? Okay, great. I'm wondering if you want me to do the last thing. So the last thing, I still owe you a story, I know. The last thing is we talked about interest. So if you want me to do an example in interest, give me a thumbs up. If you really don't care, you're not voting. So really don't care, really don't care. I see a couple of thumbs up. Let me just do one. I'll do one interest problem. And then I think we're due for a story. Would you agree? Okay, so let's do one. We'll just do one. Suppose you get $10,000, okay? Somebody left you $10,000. And you decide, I'm way too young to blow it all. I'm going to do that later. So you have two banks you can put it in, Bank A and Bank B. All right, what are you going to do? Okay, so this one, this bank says, we will compound this annually. That means your interest makes interest. Okay, the interest is 3.5%. And you're planning to put it in for 10 years. Suppose you're 8 years old. Somebody gives you $10,000. You know that's way too much for an 8-year-old, right? So you're going to put it away until you're 18. The second bank says we have simple interest, SI. That means the interest does not make interest, but their interest is higher. It's 4% compounded annually, or not compounded, I'm sorry, 4% annual interest, no compounding. All right, and this is also for 10 years. Which one do you go with? Okay, so in this case, the interest is making interest every year. This one, it is not. All right, so let's see which one. So let's do simple interest first because that calculation is a little easier. Interest is going to be, let's calculate how much interest you're going to get. Because whatever interest is, you just add that to 10,000. That's going to be how much you're going to get. So this is equal to how much you originally put in, the principal, so 10,000, times the percent, the rate here expressed as a decimal, times how long you leave it in, PRT. Okay, so the principal is 10,000. Can you write 4% as a decimal? Sure. This is 4 over 100. So this is a 4, and we've got 2 zeros, so we're going to go 1, 2. The decimal point goes there. This is times 0.04. The time is 10 years. So we're going to multiply 10,000 by 0.04 times 10. Okay. So when we multiply this all out, I get $4,000. Is that how much you'll have at the end of 18 years? I'm sorry, at the end of 10 years, when you're 18. I hope not, because that's less than what you put in. So you're going to have to add 10,000 and 4,000. So A is the amount. It's equal to what you put in plus the interest. That's 10,000. Plus 4,000. Okay, that's going to be equal to, A is 10 plus 4 is 14,000. By doing nothing, sticking it in a bank, you get an extra $4,000. Not bad. Okay, should we take a look at what happens if your interest earns interest? So the main thing to remember about this one is that it grows really, really slow. And when this number gets larger, then it takes off. So the question is 10 years enough for it to really start taking off, or is it not quite enough? Okay, yeah, it basically, you ever tried to watch grass grow? You ever heard like the term, yeah, it's like watching the grass grow. That means that it's really, really slow. Let me show you, where's another piece of paper? Yeah, grass grows really, really slow, right? So if this is time and this is dollars, compound interest is real, real slow. It's like watching the grass grow, and then you look away and it goes like this. So the question is, where's 10 years on this scale? Is it down here where it's growing like grass, or is it here where it's like, oh, wow, that's impressive? Okay, so that's what we want to know. Okay, so compounding annually, the equation for that is a little bit different than this one. It's A is the amount equals how much you put in, that's the principal, okay, times 1 plus the rate, but look here, the t goes as an exponent. See before here that the t was multiplied? This is how it's different. Okay, so the amount is 10,000. You're going to multiply that by 1 plus r, 1 plus 0 point, so this is 3.5. Okay, 3.5% over 100. Okay, so I've got 2 zeros here. This already has a decimal point in it. Okay, so you write the number, 3.5, and then you go 2 shifts this way, 1, 2. So 3.5 over 100 is equal to 0.035. So here's your interest rate. Okay, so we're going to put 0.35. Time is also 10 years. How do you do that on a calculator? Okay, let me show you. So we're going to clear that. I'm going to say 1 plus 0.035. I get a number. Then I hit this button here. It says YX. Yours might say EXP. It might say X with a little Y on top, whatever it is. And then you put in the 10. So it's going to multiply this number by itself 10 times for you. You take that number, you multiply it by 10,000. Okay. And I have a number. Let me write it down so you can see it. 14106. Okay, so can you see both of them now? So who would you go with? To be honest, because these numbers are so close, it doesn't really matter. I would go with the bank that is nicer and friendlier. Because after 8 years, we only have a difference, or I'm sorry, 8 years, 10 years. After 10 years, we only have a difference of like $106. You know, I would rather go with a bank that's friendly, that has the chocolate chip cookies every time I go in. That's the bank I would choose. If my bank does that, by the way. They have fresh homemade cookies every Friday because they know on Fridays people come in. All right, so for this one, it looks like they are right at the right point. I think if you extend this to 12, 14, even 20 years, this one's going to shoot up way faster. In fact, can I do that really quick? I'll just do the calculations on the side. For 20 years, let me do this one. 1.035 yx 20. You want to see what it is? Times. So after 20 years, this one becomes $19,900. So after 20 years. After 20 years for this one, I'll just do it really quick. This is equal to, just because I'm curious, I can't help myself, times, let me get the percent right. Okay, this one is $18,000 flat. So now this is enough. $1,000, almost $2,000, that's enough to make me go over here. So you see this is right at the point where it's starting to go crazy. Yeah. All right, and that's it. That was our percent. Yay! This is from the Supercharged Math website. We're in Unit 3%. I'm going to replace this video down here. This review will be down here on the main Unit 3 page. As soon as we're done, I'll put it on there. This review will be up there. You can watch it at any time. I hope you've had a good time. If you have specific questions that didn't get answered, I tried to answer as many as I could during class. Let me know. I'm Aurora at Supercharged Science, and I will see you in our next class. Bye-bye, everybody.